Hello, so today we are going to discuss about a very important chapter of grade 9th, that's gravitation. So whenever this word comes in your mind, what is the first thing you think of? Gravitation, Newton, apple fell on his head and he started thinking, right? But Newton was not the only one who has found it. There were many people behind it. Even Galileo was the one who was trying to find out the answers for it. But yes, Newton has given us the formula and physics works with formula. So we can also say it's the Newton's law of gravitation. Let's start the chapter without delay. So from the name itself we understand when we have got two masses, let's take it as m1 and m2 separated by some distance r. So whatever is the force acting between them, so that can be attractive and that will be attractive. You thought of repulsive, right? So gravitation force is always attractive, not repulsive. So the forces will be attractive. Now as we are talking about the attractive force because of the presence of the mass, that's called gravitation. It was found by Newton and others also, but Newton was the only one who gave us the formula. So let's go to the derivation of the formula without any delay. So I have taken two masses m1 and m2 as you can see it here, and these two masses are separated by some distance r. m1 is the mass, m2 is the second mass and r is the distance. Now how much force is acting between them, we need to figure it out. So in order to understand that, writing formula we can do it anytime. Let's understand in a practical way. So this hand is mass number 2 while this hand is mass number 1. It can relate here if you can see that, right? Mass number 1, mass number 2. Now this is the size of mass number 1 and this is the size of mass number 2. Now mass is bit confusing to understand, isn't it? Let's change mass as a magnet. So I have got the first magnet here, second magnet here. This first magnet, if I have removed the smaller magnet and brought a bigger magnet, so bigger magnet will be having more power. So what will happen between the forces between them? As the size of the magnet has increased, the force between the two magnets will also increase. Similarly, if this mass m1 is increased in the size, the force between m1 and m2 will also increase. That's the first thing. So what we understood, that force is directly proportional to the product of masses. I hope that's quite clear, right? Going to the next part, again the two masses, this time we are increasing the distance. As we are increasing the distance, what's going to happen? Here, as the distance is increasing, the force will decrease. But why? So if you remember that I have got two magnets and I am bringing them closer, all of a sudden they hit each other because the force increases to that level that it can even pull the magnet. The same thing, if we are moving them away, the force decreases that it will never come close to each other by its own because we have moved it to a very far distances. The same thing here, if the distance is increasing, the force is decreasing and vice versa. So force is inversely proportional to distance square. So these are the two formulas that we got. Now this was my formula number 1, where what we understood that if the masses are increasing, force is also increasing. So force and mass are in the same line and we can say they are directly proportional to each other. Doesn't matter which mass is increasing, any of the mass will increase, force will increase by default. Similarly, here force is increasing and distance is decreasing, or distance is increasing, force is decreasing. Means if one thing is increasing, like distance has increased, force is decreasing. If one thing is increasing, the another thing is decreasing, we call it to be inversely proportional. That's point number 2. So we have got two formulas and we are going to collect them together. So force is directly proportional to the product of the masses and inversely proportional to square of distance between them. This is the thing we got. Now as we are going to remove the proportionality sign and we are going to make it an equal to sign, we will get a constant and that's G. Because we are talking about gravity, so we will get a universal gravitational constant G along with the relations that we have already found. m1 into m2 by r square. So that's the force acting between two masses kept at some separation r. The force is equal to G m1 m2 upon r square. Now this G, this capital G that you saw is nothing but universal gravitational constant. The meaning for this is, wherever in the universe you can go, you can be on Earth, Moon, Pluto, you go to any other planet, in anywhere in the universe, the value of G will not change anywhere, it will be fixed. What's the value of G? The value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now sometimes we also say, sir, G is equal to 9.8 meters per second square, isn't it? So if you see, this is the capital G that represents universal gravitational constant, while this is a smaller g that represents acceleration due to gravity. Now how this acceleration is found? That's also a very big question. How this acceleration we are going to find, sir? So if you remember, on Earth, by default the acceleration due to gravity is 9.8 meter per second square, or approximately it's 10 meters per second square, isn't it? So as the values are fixed, it can be derived by a simple formula. Let's discuss. Calculating the value of small g, that's acceleration due to gravity, from formula of force. Is that okay? Now when we are going to discuss about this, what is the first thing we discussed? It was F is equal to G m1 m2 upon r square. That was the first formula that we have discussed. And there is a very basic formula of force that we have read from the very starting of the life, isn't it? Force is equal to ma, mass into acceleration. I am making it as equation number 2. But in our case, as we are talking about acceleration due to gravity, so this is the earth, and we'll just try to write the things or substitute the values here. And if this is the earth, this is the center of the earth C, and this part is the radius of the earth R. So if you are standing at this location, if you are standing at this location, you are standing at this location, from all the three locations, the object will be pulled towards the center of the circle or center of the earth in our case. So this radius that we can see, this distance that you can see between mass number 1 and mass number 2 is nothing but the radius of that particular planet, in our case earth. So what we can say, that force on earth is equal to G mass of the planet into mass of the object upon radius of that planet square. So G m1 m2 by r square. So this G will be constant as it is. M1 I have taken as mass of the planet, m2 I have taken as mass of the object, this is the object, and r is the distance between them. So this distance between them is nothing but the radius. So that is the radius square, if you can see that. Now this force is also equal to mass into acceleration. So mass into acceleration due to gravity. As it was acceleration due to gravity, I am writing it as mass into acceleration due to gravity. Now this mass, is it the mass of the planet? Is it the mass of the object? Bit confusing? So let's make it clear. If I have given you a weighing machine and you have stood on it and said, sir, my weight is 70 kg. So that what was your sentence? My weight is 70 kg means here the mg represents your mass, and this g is acceleration due to gravity. Your mass into acceleration due to gravity gives your weight. That is the force of attraction towards the center of the earth of your body. Now in this case, your mass and your mass will get cancelled. So acceleration due to gravity small g is equal to capital G, that's universal gravitational constant, into mass of the planet by radius of the planet square. If you substitute the value g, m and r square, you will end up getting the answer as 9.82 meters per second square. So this is how we are going to discuss about gravity chapter, and that's the beginning. There are a lot many things to come. Like if you go to this part here, this gravitational force acts from the center of one object to the center of the another object. That's the reason why when we come at this location, so the force was acting from center of the earth to the center of the body, and that's the reason why we have taken the distance as r. So there are such small things that will come up when we are going to discuss, and these are just the beginning. Once you start understanding the things, it will be quite easy for you to solve the numericals. So don't delay, and you can start learning it today. Thank you.